Hey guys, welcome to CodeChef's YouTube channel. The problem that we're going to discuss today is chef and pairwise distances. The problem appeared in September 21 Cook-Off and has a difficulty level of easy. The prerequisites to solve this problem include Manhattan distance. The problem statement goes as follows. Chef has array A with n elements. Now he wants to find n points p1, p2 up to pn such that they should be on a 2D coordinate plane, and for all pairs I, j, the Manhattan distance between point pi and pj should be exactly equal to ai plus aj. So we will be given an array. So let's say the array is something like this. It's a1, a2, a3. There's some ith element, ajth element, and then finally an. Okay, total n elements. So we have to find, or rather we have to plot n points on a 2D coordinate plane. So each point will definitely have an x coordinate and a y coordinate. So x1, y1, x2, y2, and so on, such that between each pair, for each pair I, j, so let's say the pair can be very random. Okay, so let's say it's some ith point and some jth point. So between these 2 points, this will be the point xi, yi, and the point xj, yj. So between these 2 points, the Manhattan distance between them, which is given by this formula again, the absolute distance between their x coordinates and plus the absolute distance between their y coordinates. So sum of that, it should be exactly equal to ai plus aj. Okay, that is the ith element in the array plus the jth element in the array. So, and this is just one pair. Like this, it should be valid for all possible pairs. That is 1 2, 1 3, 1 4, 2 3. Okay, all possible pairs. So we have to find if such a arrangement exists of n points that you can plot. If it exists, you have to print yes that it exists, and then you have to also print the n points, that is point p1, p2, p3. Okay, and if it does not exist, you have to simply print no. So if answer exists, you have to print yes and then output n different points, that is point 1, point 2, and up to point n. If not, you have to just simply print no. So the question is pretty clear. Now let's move towards the solution approach. So the solution approach goes as follows. First of all, the key to solving this problem is that you have to draw stuff. Okay, even though the problem is given in terms of mathematical terms, but it will help if you try to graphically represent what it is trying to say. So we are going to take the same approach, that is we are going to try and draw the figures, that is try to actually plot the points. So let's say the array given to us, I'm taking a small example, it consists of 5 elements. The elements are 2, 3, 1, 4 and 3. So the first point I can plot it anywhere. So let's do one thing, I'll plot it over here. It will be represented with the red color. So this is my first point. Okay, so let's say this is the first point. Okay, and because it has the value 2, that is the a1, the value of a1, this is a1, this is a2. Okay, so these are the 5 values in the array. So because this first value in the array is 2, let me draw a kind of boundary, or you may call it like a Manhattan circle of distance 2 around this point. So how will it look like? Even though I'm calling it as a Manhattan circle, in this case it will actually look like a square, because all the points that lie at a Manhattan distance of 2 from this point are actually on a square. So this point, this is basically the square I'm talking about. Okay, this is the square I'm talking about. So the red point is my point number 1. Okay, let me give the coloring over here. This is my point number 1. Okay, and I have drawn a kind of a perimeter or a circle of radius 2 around it, but it's not a normal circle, it's a Manhattan circle. So it will look like a square. It is exactly a square. Now let's try to draw the second point. Now remember, when you're drawing the second point, the condition should be fulfilled that the pair, that is point 1 and point 2, they should have distance of 5 between them, that is 2 plus 3. okay, according to the question. So the point should be such that their squares touch each other, okay, not intersect. They should touch each other, because if they touch each other, the sum will be 2 plus 3, that is 5, because I have already drawn a circle of radius 2. Now I will be drawing another circle, or let's say square of radius 3, and they should touch each other. So okay, let's do that. Let's say the point is over here. Okay, the second point is over here. So how will the square look like? It is going to look like this. Okay, it is going to look like this. So if you see, the distance between the red point and the blue point is exactly 5, and that's what we want, right? 2 plus 3 should be 5. The coloring, let me give over here. This is, the color is blue. Okay, and it is satisfied. You can see for yourself. You can pause the video and check in this diagram. I have given a grid in the background, so it's easy to visualize. You can calculate the distance between, the Manhattan distance between these 2 points is 5. Now what if I try to draw the third point? The third point has a radius of 1 around it, and it should satisfy the condition that when paired with the other two elements, that is with first element and with the second element as well, it should satisfy the condition given in the question. So the condition can be seen in graphical way in as follows. So 2 points are at a distance x plus y with each other if their circles of radius x and y are touching each other. Okay, so here the squares were touching each other. Similarly, now the third square that we are going to draw, it should touch not only the first one but also the second one, because all pairs should satisfy the criteria. So definitely I think you are getting the idea where I am going. The third square, the ideal position to put it would be over here. Okay, I'll put it over here. I'll put the third one over here. Okay, sorry, not there. Over here. So the square will look like this. Can you see the green square? Yes, you can. So this is my third point drawn. Okay, and again you can see that the distance between any pair of points is satisfying the criteria of the array. Okay, you can take any pair and check for yourself. Now quickly let's draw the fourth square. Now the fourth square will have radius 4. Let's give it the color yellow. Okay, let's give it the color yellow. And there is only one place where you can put the fourth square such that it touches all the previous 3 squares. That is, it should lie in this remaining quadrant. Okay, so it will be something like this. So the point will lie over here, and the line will look something like this. Okay, so yeah, it looks like this. So far so good. That is, all the possible pairs are covered till now. So if you see, if I draw in the array all possible pairs, these are the pairs, right? These are like the all possible pairs that you can see. Okay, just pair all points with each other, and you can see that they are satisfying the criteria given in the question. That is, distance between pi and pj should be equal to ai plus aj. But what if I want to plot the fifth point right now? The fifth point, that is the number over here is 3. I can draw the square of radius 3. Okay, it will look something like this. I'm just roughly drawing. But where will you place it such that it is touching all the initial present squares? Okay, not intersecting. It should touch them. Only then the criteria of this addition will be satisfied. Okay, now it's easy to guess, right? Definitely the answer is not possible if there are 5 points. You can only plot points according to the given condition in the question if n is less than equal to 4. If n is greater than 4, the answer is no. And in other cases, that is n less than equal to 4, the answer is yes. As you can see that I have demonstrated right now in front of you. I just kept on plotting the points one by one, keeping in mind the condition given in the question and representing it graphically. So graphically the squares should touch each other. So that's it. That brings us to the end of solution. The solution is simple. If n is less than 4 equal to 4, the answer is yes. And plotting the points is quite trivial. You can just plot them on the axis. Okay. So whatever are the points, let's say there are 3 points. Okay, 3 points given to you. These are the coordinate axis. So what you can do, you can plot 1 point over here, 1 point over here, and 1 point over here with their respective values and signs, of course. So here the sign would be negative, here it would be positive, y positive, and x positive. Here it would be x negative. If there are 4 points, the fourth point would come over here. So just plot them on the axis, and that's it, you're done. And for other cases, that is for n greater than 4, the answer is anyways no. So that is pretty much the solution. The implementation looks like follows. We take the input for n, create an array, take the array input, just check if n is greater than 4. If n is greater than 4, straight away output no, else first output yes. Then there are these 4 directions present on the axis. Okay, I've just represented them in form of pairs. You can pause and look for yourself why this is working. And then these are the variables that in x and y, definitely. So just output the ai into dx and ai into dy, where dx comma dy is from this d4 array. Basically d4 represents the 4 directions along the axis, the positive x, positive y, and negative y. So that's it for this question. Whatever are the points, the first that many directions will be taken in consideration and will output the points. So I hope you guys understood the solution. If you have any doubts, you can post them in the comments below. I'll try to answer as much as I can.